Hi, Top Realized Math Industry, and we are going to do part 2 of electron configuration. So in the last video, we were talking about the structure of an atom, but we're also trying to understand how many electrons are in that atom, but also where and how is the electrons placed on each of the different energy rings, or the energy sublevels. So we've been left off with this mysterious secret code. What does that mean? Well, the secret code tells us that S, and P are actually sublevels. So here's what happens. Remember when we were talking about the different shells, when we were learning about orbitals? Areas where probability of an electron actually be located, where they're actually being floated around, like maybe here, here, and maybe here. The thing is, we're going to understand that these S, P, D, F is actually going to be these three numbers right over here. So here's what's going to happen. We're going to say, for this one, it's going to be 2 electrons in 1s block. We are also going to say 6 is going to be in the 2p block. And we're also going to say is 2 in 2s block. But why am I saying the word block? Because turns out there's nothing here. Those blocks are basically up on my dresser, but not those kind of blocks. But why do we call them blocks? What happened to the S block, and the P block? Well, if you take a look at the periodic table, you might notice that the periodic table has been divided into giant sections of different blocks. We have the S block, the D block, the P block, and the F block. So it's saying that these are going to be how the electrons are configured. And we can actually find out what element is hiding behind this code or kind of equation. So we gotta find out how are we gonna find it on this periodic table of elements. Going back from the last video, we said that these are gonna be the different sublevels, telling you how many different layers that the atom has, like 1, 2, 3, for example. So to understand what this hiding element is, right over here, there is an actual strategy. There's no math in it, and there's no direct formula. But here's what we're going to do. First things first. To understand it better, we are going to move helium to the other side, because helium is actually part of the S block, because it is part 2 an alkali earth metal. So here is how we play the game. So to play the game, we have to read the periodic table from left to right, as if you're writing your essay in English class, or you're reading your independent reading book in English class. So we will start on the top of number 1. And if we ever get to the end, then we'll make the second layer. So here's what we're going to say. We're going to say S block 1, S block 2. So we are going to say S block 1, S block 2. Let's write that down. 1, S, 2. So there are going to be 2 elements that we jump in the S block. And we put the number 1 in the front because that is the first layer of these sub-energy layers. Then we have to move to number 2 because we moved helium to the other side of right over here. So we're going to say 2s1, 2s2. So we're going to say 2s2. But the problem is, we are no longer in the S block because that so-called S block. If we continue on the row for number 2, we will eventually end in the P block. What? So we're going to say 2P1, 2P2, 2P3, 2P4, 2P5, 2P6. So 2P6 is going to be the last of our mystery equation. So if we got this as a result, we stopped on neon, which is going to explain that this element, this hiding element, is going to be neon. And that is how neon is going to be configured with its electrons. On the first S layer, 2 electrons. The second S layer, 2 electrons. And the third one, 2P, is going to have 6 electrons. The reason why that has happened is we had to follow the rules. The S layers are going to have 2 electrons. The P layers are going to have 6 electrons. The other part of it is, notice how the S block only has 2 jumps until you move to the other side of the periodic table. So 1, 2, 2 electrons. For the P block, we have 1, 2, 3, 4, 5, 6. That is going to be for the P block. 6 jumps because we have 6 electrons at the max. The D block is the biggest in area of the periodic table. We're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is going to be our answer for D. But the problem is F is going to be a lot larger than D in terms of length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 jumps, 14 electrons. Let's try to solve another problem. But instead of finding the element just by getting the equation, we're trying to find what the equation is if we're trying to find cobalt. Is it pronounced cobalt or cobalt? I don't know. So, trying to find cobalt. If you look on the periodic table, cobalt is going to be around, where is it? Number 27, right over here. So, that arrow I drew here, I drew it before we made this video, because we're trying to find cobalt. So, let's get started. From the top, let's start. 1s1, 1s2. So we're going to say 1s2 because, remember, helium went to the other side. So 2s1, 2s2. So we're going to say 2s2 because we reached the edge of the S block. However, if I go to the other side of row number 2, we're going to say 2P1, 2P2, 2P3, 2P4, 2P5, 2P6. So we're going to say right here 2P6. But we're not done yet because we are at neon and we're trying to get to cobalt. So here is another one. 3s1, 3s2. So we are going to say 3s2. This is taking too long. Now we have to go to the other side and say 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. So we have 3p6 as that one. So that left us at argon. Now we go on row number 4. 4s1, 4s2. So we're going to say 4s2. Now, problem. Wanna know why there's a problem? Because we have the D block right in front of us, which is getting us in the way. But we can't say 4D1. The reason why is if you check right here, when you have a transition metal, you have to go below the layer that you're on. So in reality, instead of saying 4D1, we literally have to say 3D1, which is such a pain in the neck. So going back to what just happened, we're going to say 3D1, 3D2, 3D3, 3D4, 3D5, 3D6, 3D7. So we have arrived at cobalt on the last step of the answer as 3D7. So this is going to be the electron configuration of cobalt, the different limits on the different energy sublevels, and now this is going to be the answer for the configuration of cobalt. But that took way too long! Just so you know, when you're messing with the D block, you have to subtract by 1. And guess what happens? You have to go down from 4 to 3. But if you mess around with the F block, instead, you have to subtract by 2. So instead of saying, this was originally going to be 6, and this one right here below it was going to be 7. But the problem is, 6 minus 2 is 4, and 7 minus 2 is 5. That's because this F block was supposed to be right here in between hafnium and ruthenium. If I put the F block in the periodic table, the continental periodic table, it would expand way too far, making all those chemistry posters more expensive to make. Therefore, it would be harder to see because it's way too long. So 6 minus 2 is 4, and 7 minus 2 is 5. So then we'll have to go back down 2 levels by 2. We have to pull back again.